Okay, so we're gonna use the definitions of mean, median, and mode and kind of try to do the problem. So actually, we're gonna break it into cases and then try it. Here we're trying to use our answer choice to our advantage. No, so first off, it can't be either 5 or 7, and the reason for this is the question says there's a unique mode, and if x was either 5 or 7, then there would be multiple modes because there's 2 6s. So it must be like any of the other 3. So let's try 6, the case where x is equal to 6. So definitely the mode is equal to 6. And that means the median is probably 6 too, and we can check that out. Is it 3, 4, 5, and there'd be 3 6s and 7. So if we cross, that is our median, so that's good. How about our mean? Let's check that out. Maybe we're at the answer already. 3 plus 4 plus 5 plus 6 plus 6 plus 6 plus 7 and divided by 7. So that would be 12 plus 18, 37. So 37 over 7, and that's not equal to 6. So unfortunately, x equal to 6 doesn't work because they say that all of them are equal. So this is wrong. So let's try x equal to 11. So our mode would be 6. Our median would be 3, 4, 5, 6, 6, 7, 11. So 6. And our mean is equal to, so well, it is 31 plus x over 7. So x is equal to 11. So 31 plus 11 over 7. So that's 42 over 7. And that's equal to 6. So all of them are equal. They're equal to 6. So 11 is our answer. So here we're just using the definitions of mode, median, and mean, and attempting to figure out what x is by trying different values. Let's read the next question. Hammy is in the 6th grade and weighs 106 pounds. His quadruplet sisters are tiny babies and they weigh 5, 5, 6, and 8 pounds. Which is greater, the average weight of these children or the median weight of these children? And by how many pounds? So for this one, it's just a plain simple application of definition. I'll give you some time to think about it and then we'll go over it.